Hello viewers, this is an earlier version of de-welding machine made from two identical microwave transformers, which is connected in series. As you can see, the machine is not properly maintained after the first installation, and the airflow is not effective as I had expected. So I decided to upgrade it and started building a new frame from standard design out there. For this purpose I choose half-inch square pipe and weld it according to my design. Now you can see the finished framework. Later I cut off a piece of aluminum sheet from scrap and screwed it on the base of the frame, where the transformers are mounting. Since the transformers produce a huge amount of heat, so I place it on a heat sink before mounting it on the plate. The secondary is winded with 6 SQ/mm electrical wire connected in series to each other. The purpose of new core is to increase the power output and efficiency, hence, reducing the heat loss. I fitted the third core off camera. This is one of the new upgrade to this system. For safety measure I connected the metal part of the cores together, which will eventually connect it to the earth terminal. I securely connect the terminal with soldering iron and covered it up with heat shrink. The input for the transformers are connected parallel to each other from a 220-240 VAC power supply. The fourth core is actually built as an inductor, which will theoretically reduce the sudden changes in current flow through the cores, therefore the welding arc could be controlled. The next step was assembling the front panel, which consists of cooling fan and terminal out for welding. After that, back panel, which also consists of an identical fan and slots for MCB and 3A DPST switch. The terminal outs are connected with aluminum wires, since the copper wire of similar gauge would make this project a bit expensive. Front display panel is cut off from an old LCD TV frame. It was done off camera and the process was pretty simple. I cut off the necessary space for switches, digital display and analog ammeter, with the help of angle grinder and files. I roughly assembled the switch and all for finalizing the product. Once I was satisfied with it, I assembled the panel onto the frame and roughly screwed on it. Then the MCBs are connected on the back panel as well. In order to connect the cables, I rearranged the wires for better accessibility and placed the temperature sensors on the other side for later. I connected one terminal of the newly wounded transformer to the one part of both the switch and the other part connect to the old transformers. The purpose of the switch is to disconnect it from the core whenever it is needed. See the parallel connection part, where I connect the three terminals of all three cores together with nut and bolt, similarly for the second terminal. This is almost the final steps. I mount a plastic C-sectional part on the top for mounting the relay for the welding purpose and the power supply for the cooling fan and the temperature controller. Since the cooling fan required 48 VTC, almost 180 W power needed, so I stepped up my 120 W 12 VTC power supply to 30 VTC with the help of a boost converter and connected to the fan. The relay also needed a 12 volts power supply, so I connected with a separated power supply as well. Furthermore, the temperature controller also needed 12V power supply, and I connected it with separated DC power as well. And rearranged the wires and tape it up together, forming a clean look overall. Final step was to place the temperature controller on the cores with thermal paste and one with resin hardener